Hello and welcome to the second episode of Exploring Machine Consciousness with the Partnership for Research into Sentient Machines. Today's the first time that Callum, Chase and I will be hosting together, and we're going to be the regular hosts going forwards. Callum is the co-founder of Contium, a company pioneering safe and efficient AI through agent verification, machine consciousness research, and neuromorphic computing. He's written several best-selling books on the future of AI, and is also the co-host of the London Futurist podcasts, who we collaborated with for our first episode. It's great to have you, Callum, and I'm going to hand over to you to introduce our guest today.
Thanks, Will, and I'm looking forward to exploring machine consciousness together. For this episode, we are thrilled to be speaking with Professor Susan Schneider. Susan is the founding director of the Center for Future Mind at Florida Atlantic University, where she also holds the William F. Dietrich Distinguished Professorship and is co-director of the Machine Perception and Cognitive Robots Lab. We are also delighted that Susan has agreed to join PRISM as a scientific advisor. Susan's work explores the nature of the self and the mind from the varied vantage points of philosophy, AI, cognitive science, and astrobiology. In her book, Artificial You, AI and the Future of the Mind, she discusses the philosophical implications of AI, and in particular, the enterprise of mind design. So, Susan, welcome to the Exploring Machine Consciousness podcast.
Hi, really nice to have this chance to talk to you both.
It's great to have you, Susan. So I'm just going to kick off with the questions, and our first one is kind of to get us all on the same page. So consciousness is a contested subject. So what's your definition of consciousness, and what mechanisms do you think causes it?
It's a good place to start. So I take consciousness in the same way that many philosophers of mind do, as being the felt quality of experience. So when you see the rich hues of a sunset, when you hear the sound of your favorite music, when you stub your toe, throughout your waking life, even when you're dreaming, it feels like something from the inside to be you. And that's the felt quality of experience. And that seems to most philosophers to be the essential ingredient of conscious experience.
So to build on that, kind of what mechanisms do you think causes that subjective experience?
Good question.
We're starting with the easy ones.
Yeah. So, boy, I have a new paper that is the target paper of the Journal of Consciousness Studies special issue that's coming out, I think, in the fall, and it's already available on the web, and it's called Super Psychism. And in my paper, I argue that consciousness is actually a matter of quantum coherence. So I begin with space-time emergence, which is something I had the opportunity to study when I was a member at the Institute for Advanced Study. And I've long been fascinated by the work of string theorists and those in loop quantum gravity. And being also a philosopher of mind who thinks about physicalism and panpsychism, I've noted that almost everybody in the debate about the nature of consciousness agrees that consciousness supervenes on the fundamental physical level. So bringing those together, the fundamental level, as far as we know, is what lies beneath space-time. So again, I'm interested in space-time emergence theories. So for me, that's quantum entanglement, and that's a commonly held view within physics. So I try to recover consciousness from the delicate dance of fundamental particles. But that's just my own view, together with Mark Bailey.
Does that mean that you would consider yourself a panpsychist?
I am indeed something like a panpsychist. So for me, I take the fundamental level as not being a level that has time's arrow. It's time without its arrow. And so for me, the fundamental ingredients are ingredients that are not quite what the traditional panpsychist has in mind. Because when you think of experience, you might think of it as always moving forward. That's the classical phenomenology. It's not there yet at the fundamental level, but interestingly, I argue that the network of entanglements at the what I call the proto-temporal level, I call it proto-time, is more conscious than any classical ingredient. And I argue this simply on the basis of commonly held views within physics. So, one is that uh, states that are entangled when in a pure state have zero von Neumann entropy of the whole system. The other is that times arrow is a feature that emerges with the introduction of entropy into a system. And so putting these together with the commitment that space-time does emerge from quantum entanglement, which is commonly held by a lot of physicists trying to deal with the contradiction between relativity theory and quantum mechanics, I say that the fundamental level is actually superconscious, hence the name super psychism for the view. So that's my new take.
Fascinating. I want to dig into a couple of things there. One is what does it mean to say time without time's arrow? That's my first question. My second question is, if consciousness pervades everything because it's part of the quantum substrate that we all live on, how does it fluoresce up into something more, at least evident, perhaps more sophisticated and richer in a human brain than, say, in a rock? Why does it seem to be more of it in one substrate than in another? Sounds like you need to have another theory on top of the panpsychist theory.
That's a great question. So to begin with the second one, so I think that you get consciousness and all of space time, indeed, the entire classical world by appealing primarily to a view called quantum Darwinism, which goes from the entanglement level to the interaction of many bodies. And it explains the dynamic interaction toward basins of attraction with decoherence and how activities at the very small level actually are formed. So I'm writing a paper right now called Quantum Darwinism in the Brain to describe it at the level of the brain. And now, how do you distinguish between the consciousness of a rock and the consciousness of an entity with a nervous system? That's a great question. The same way that any scientist would, right? Talking about complexity in nervous systems. So ultimately, with the quantum Darwinism in the brain paper, I talk about how there's this delicate dance among particles, and then you do have quantum phenomena in the brain. It's not quite. It's designed to deal with some objections to Stuart Hamerob's view about having doubt that quantum phenomena could be entangled within the brain. So I say, well, actually, it's everything starts with entanglement, but it decoheres and then forms into there are basins of attraction as per quantum Darwinism. And then from there, you get networks of resonance in the brain ultimately. And that's where it gets to neural oscillations. And I quite like the general resonance theory of consciousness and the kind of view that you see with Jonathan Schooler and Tam Hunt. And my view is actually sort of a version of that perspective. And the paper talks about that. So as many people say, read the paper. It's in there. It is posted, and it's called Super Psychism if you want to hear more. I'd be thrilled. And I look forward to all the people responding to it right now. And I don't know if I look forward to answering all their replies, but especially since a lot of them are physicists. But it should be quite fun, right? And I'm lucky to have a great co-author, Mark Bailey.
So you decided that neuroscience wasn't hard enough. You decided to bring quantum physics in as well to make it a little trickier.
This project is hard to do. I need to find a collaborator in quantum biology now because, it's just all over the map, and that's kind of in keeping with my personality. I get bored easily. That's why I drink so much caffeine. So, I needed to just do this. There's so much new material you can learn. It's incredible. But yeah, to keep myself grounded, I definitely need someone in the field of quantum biology to talk to. Yeah.
Nice. Well, I'll post a link to that in the description of the podcast of that paper once that so that people can access it directly. So we spoke about rocks and we spoke about brains and human brains, but what's your belief on machine consciousness in particular? This is the Exploring Machine Consciousness podcast after all. And if you believe it's possible, do you have a timeline on when you think that might happen?
I think that it is actually compatible with the laws of nature and it is actually technologically possible. So in my book, I had a wait and see approach, but now that I've learned more about organoid computing, I think there will be some level of consciousness present in those systems, especially when you configure the systems together. So right now they're able to get about 16 organoids in. They're separated into four dishes and configure those. Not quite something that would necessarily achieve consciousness, but I think as that field progresses and as you're able to put more organoids into a dish and as you're able to create networks of these computers, then I think you're quite possibly at the level where there could be some interesting consciousness. It might be akin to something like, um, a rat eventually, and then we can build up from there. And it will be imperative to test. So that is something that I am willing to say is tech within the scope of our technology. But notice I've said nothing about GPUs. I'm still quite skeptical about GPUs. So, the view I had in the book was that we really do need to proceed on a case by case basis when it comes to consciousness. I still believe that. And so I don't think there's a blanket answer really to questions like, will machines be conscious? Right? I mean, we have to actually divide and conquer, and we need to run tests.
I suppose the really interesting question is, can machines, or can and when will machines become conscious at a human level, if it's possible to quantify it? Organoids are unlikely to get to be human level scale. I mean, I don't think anybody's in the near future going to put together 87 billion cells, neurons in an organoid system. So you would need something more like a traditional, a large language model or something else to have the scale to support human level consciousness. Your withholding judgment about GPUs, fair enough, but using, I don't know, CPUs, GPUs, or neuromorphic hardware, do you think in principle it's feasible to get human level consciousness in a machine?
I think the professional thing to say now is that we have to consider it. I also think that the questions are emerging with the public. I get zillions of emails each day. I mean, people are interacting with large language models, and it's raising big time issues about consciousness. And, fast forward to the point at which we develop super intelligent AI. And at that point, it'll be a cultural crisis, something that potentially outthinks us or outmodes us in the workplace, even if it's not super intelligence. That could be a cultural crisis. May seem to many to be conscious, and it's very important that we gain clarity on the subject. I would also add that, I have a case for skepticism about LLM consciousness that I'll tell you about. But just first, let me add a case that might be quite possible. So take the organoids, wire them up to LLMs. You see? Right. What would that do? That's why it's important that we have consciousness tests, right? Because hybrid systems are all the rage. And indeed, to be honest, I mean, you know, we if big tech, if the large language models are hidden, the structure is hidden, we really don't know what we're dealing with in terms of the actual system itself. I mean, for example, is it a mixture of expert system? Is it a hybrid system? I love Marvin Minsky's Society of Mind view, and I think that's the way to construct intelligence, right? But what's in the society exactly? I mean, big tech's not letting outside observers look at the details of their system.
So clearly, having a test for consciousness is extremely important. We really don't want to develop consciousness in machines and not notice we've done it. That would be really disastrous. And also, I imagine actually you would quite like to have a test of consciousness so that you can have a blanket response to all those zillion emails you get every day. I'm quite interested how you respond to them. Do you respond to them all individually, or do you have a sort of a blanket reply that you send out?
Oh, Callum, that's such a good point. I probably should have something ready for people because so many nice people are writing me. I also get some strange emails, some bizarre ones. Hey, open this attachment. I'll show you my new, you know, but I haven't been routinely writing back just because it's such a time commitment. I did, though, write a piece for Scientific American recently to try to answer the queries that people had, which I'm happy to talk about. But yeah, I should have a generic response. I should.
The only thing is, I think if you did write back, then you'd get 3 more inbound, so it probably wouldn't really work. But let's talk about tests, because you've actually devised one, the AI consciousness test, or ACT. Tell us about that and why you think it would work, and how it would work.
Sure. The ACT test, or I should say the ACT, because it's just AI consciousness test, was designed with my dear friend and colleague Edwin Turner while we were at the Institute for Advanced Study together. And he is a professor of astrophysics at Princeton who loves AI. I think he was a student of Marvin Minsky when he was at MIT. So, it's just based on a conversation that Ed and I had. And according to that test, um, we believe that if you ask the AI a range of questions designed to not locate intelligence the way the Turing test was, but instead locate whether it's sensitive to the idea of a felt thought of experience, um, then it would indicate whether or not the machine was conscious. However, when we wrote the test, this was back in 2016. We put it in at first, it was published in Scientific American. I said very clearly, you can't give it to a large language model that's been already hoovering up all the data about consciousness and neuroscience and whatnot. Okay. Because then it's going to spit back answers. And indeed, this is what we're seeing. So I did say that, and some people say, well, then the test is useless. And let me just say a few things in response, real quick. First off, there are lots of different systems out there, symbolic, our hypothetical hybrid system that includes organoids. It could have an LLM attached that hasn't been spoon fed information, or you could just run the test on a version of GPT. There are all kinds of things you can do, but you just have to isolate the data that you don't want in there, right? Or just do it at the R&D stage. So I claimed in the original paper and in my book, where I published a lot more questions and a lot more detail, that you need to box in the AI. That means, keep it apart from the data on mind and consciousness, and then see if it does respond in a way that indicates consciousness. So that's the ACT test. I also have another test called the CHIP test as well. And I'm happy to delve into the case of LLMs more, because I am actually very skeptical of today's LLMs.
I mean, I'm sure Will and I would both like to know about the chip test, but before we move off the ACT, I think you're right. You've got to avoid testing a machine which has already read everything humans have ever written about being conscious and dealing with other conscious entities. Otherwise, it will just be it'll be too fluent in answering the test, answering the test questions. But how do you do that certainly with an LLM? Training these things, they swallow the whole internet. It's not really possible to take out the bits of the internet that deal with consciousness. So how would you train a model so it's got the scale of an LLM, but not train it on, not give it lots of insight into what humans have said about consciousness? That's a tricky maneuver.
There are different ways this can be done. So one is you can take a baby LLM, like a smaller version, right? And you can not provide it with all of the data, right? Other ways include, well, let me just start with that way. Okay, so suppose you ran that on GPT-3. Now you might say, and here's what critics say, and suppose 3 doesn't have the data in it, okay, because you carefully curated the data. All right, you could do that. But then the critics would say, well, suppose you get a pass, Susan and Ed, your test doesn't say anything about the really interesting LLMs right now, like the state of the art ones. And I would say in response, if we get something that's silicon based that passes the act, that's incredible. It's showing us that a baby version of the stuff that we have right now and that's widespread on the internet satisfied the act. So why think that the later versions that are more sophisticated don't? Okay. So that would be incredible. So it's funny though, people who write about it just miss all that and just blow past it and try to refute the ACT test based on my very points that I raised in 2016 and in my book that you have to box it in. or oh no, we should not look for a single test. Yeah, that was the point of my book. It was that you have to develop a whole toolkit. You have to check the tests against each other. So I advocated the chip test. I suggested we use Tononi's measure as well. Let many flowers bloom, test them against each other, and ask the AIs, right? I mean, we can at this point create an AI that knows a lot about consciousness, right? Even if it's not conscious, it may one day know more than any human, even if it's not
Oh, I
conscious.
think ChatGPT-4 knows more about consciousness than I do, except in the experiential sense.
I agree. I mean, I think it's I remember in Nick Bostrom's 2014 book, he demarcated different kinds of superintelligence, and superintelligence is too strong of a word for GPT, of course, but there was one category called speed superintelligence, as opposed to quality superintelligence, which is outthinking humans in every respect, scientific reasoning, and more. And I think this is a sort of early speed AGI, if you will. I don't like the term AGI either for because people think strictly human like, but I mean, it's able to provide loads of information very, very quickly. And in that sense, it does know more than we do. Right. But I don't think it has that felt quality. But I mean, it'd be really interesting to construct an artificial system through organoids and then hook it up to an LLM and have the LLM report its experience. That I would think would be a potential test right there. I'll call that the hybrid chip test. I coined it here at this discussion. Here we go.
Let's rush off to the patent office.
Yeah. Yeah, we started a patent on the ACT test with Princeton University. Yeah. Yeah, I think it's probably time. They were like, "This is so science fiction like," and I'm like, "Well, give it a few years, everybody."
Yeah, we're certainly seeing that more and more with kind of Anthropic coming out with the AI welfare officer, and we're definitely seeing it coming more into the mainstream. But on that topic, you mentioned your Scientific American article. I believe it was called "If a Chatbot Tells You It Is Conscious, Should You Believe It?" Um, so can you tell us a bit more about your skepticism towards LLM consciousness? I'm also interested in, you mentioned organoids a few times. What is it about the organoids that you think would bring the consciousness? Is it the biological aspect to them?
I'll answer that question first, the latter question. Yes, it is. It's because you take pluripotent stem cells and ultimately can create mini brains in dishes. And I think when you start to grow larger and larger ones, you start to see patterns that resemble the brain. And, you have these what are called mini brains in dishes, if you will. And I think that technology is growing in sophistication. And I believe that the ethical issues, because they're so closely related to entities that we know are conscious, brains, are urgent. These are urgent ethical issues right now. Very urgent and extremely important from a humanitarian perspective. Because to go back to Callum's point in our earlier conversation, not today, but he's deeply worried about mind crimes. I am too, even if they're mini minds. I mean, I think we have to be compassionate. And I also think that we need uh, to use organoids to run experiments to help humans with diseases, right? And to just in general to learn more about the brain. So I think that's quite urgent. Okay, and yeah, so it's the biological nature of these entities. Now to go back to the LLM issue. Okay, so here's some my thinking on LLMs right now, and I should warn you, I'm right in the middle of writing a paper on this uh, on consciousness tests. So it could be that by the time this comes out, I have a different view, and I apologize. But right now, my thinking is okay. So you have the app test, and you can't run it on today's LLM. So I think it's still really interesting to run it on curated LLMs, GPT-3 minus that certain amount of data or whatever. Okay. And I do think you could do that. All right. So what about though the class of LLMs that are talking to us all the time? I mean, this started with like Blake Lemoine over at Google, and everybody knows that story. I think people were sort of cruel to him when he was speaking his conscience, and that it's very, very natural, we're seeing, to think that these systems are conscious. And, they may have parameters that are set specifically so that they don't announce that they feel conscious, but they can be jailbroken. You should see my computer inbox. You want to see jailbreak central, or just, every user, or go on Reddit. Okay, so they're doing that. And why? Okay, so quick answer is that because they hoovered up all of our data, right? Um, Deeper is understanding, going into the mind, if you will, of the LLM. And Anthropic's done some really cool work on that. And it's very compatible with the kind of work that Jerry Fodor and Paul Smolensky and Hinton, and, back in the day when there was a debate between the symbolicists and the connectionists, we're talking 20 years ago, right? People knew these systems have a network of concepts. And I don't mean anything like philosophically robust here. I'm not claiming that they had inner experience, these systems, but they did have conceptual representations. They had a network, and it would over time, when the parameters grew, become more and more like ours. So they are capable of having a concept of dog, and in, you might call it, a large conceptual space, dog is closer to cat, furry, and other things than photon. And these kinds of conceptual structures are basically encoded in the relations between the weights. Okay. To put it very simply, I mean, this is in the Scientific American piece. It's also in a piece coming out in a few days at the journal Social Epistemology called Chatbot Epistemology. So basically, the idea here is that as the systems scale up, they do actually exhibit conceptual structures that mirror sort of all of us, right? Everybody whose data has been fed to them. So I call this the crowdsourced neocortex theory. And that means, though, that they would make avowals of consciousness, right? And this is very consistent with Anthropic's new work on circuit tracing. That's what I was also trying to say at the beginning there. So there's the older work, and there's also this newly released work on circuit tracing at Anthropic, these new papers, very compatible with that. So basically, what you have is what philosophers call an error theory. So that means that there's a reason to explain why we would erroneously claim large language models are conscious. It's because of their conceptual networks. For that reason, their avowals of consciousness do not say anything about whether or not they're actually conscious. We need real conscious tests to do that. Okay, so I don't think any longer these systems have much of a marker for consciousness in any kind of strong sense. And contra Birch and Long and others, just because, like, say you could peer into the mind of an LLM, and I think Anthropic's getting better and better at this, and I use mine loosely here. If you saw certain functional behavior, for example, if you saw a functional analog of a global workspace, or if you saw conceptual processing that was similar to humans, it still wouldn't be evidence that the LLM is conscious because you have an air theory in play. It's a crowdsourced neocortex, so it could have emergent structures that you can impose on it because of the configuration of its weights, because of its underlying conceptual structure. So there's no evidence, none at all.
So despite that, over attributing of consciousness does seem to be on the rise. You know, you mentioned you're getting emails about it all the time. We're certainly getting emails a lot of people saying that their LLMs are conscious now. So why do you think that is? Well, you've already explained why you think that is, sorry, but what do you think are some of the consequences for society going forwards of that?
Well, I think it's a mess. And I'm really glad that your organization exists and that you both are talking about it intelligently and starting to coordinate expert meetings. I think it's phenomenal. My Center for the Future of Mind and Society, we just renamed the center, also tries to coordinate activities. And, we just had a big meeting on sentience at MindFest. Um, yeah, these are really important discussions to have. So why? Why? Well, the public, like I mentioned, could create a lot of misunderstandings. And I think the most fundamental thing, first off, there's the danger of mind crime, but there's also an issue involving trolley problems. That's a simple way to put it. So think about the philosopher's trolley problem. So here you are, you're a conductor, and I'm just going to make it a simple version. You are moving the train forward, and on one track, say you get to a point where you have to decide between two tracks. Okay, this side, on the right side, are say 7 human babies. On the left are 20 LLMs that the public thinks are conscious, but which are not. What do? Well, and this is a very simple case, but if you're willing to say that these are sentient or conscious systems, and given their level of intelligence, you kill the babies, right? Okay, so obviously misjudging the consciousness issue is very dangerous. Very, very dangerous. It is life or death. I always tell my students metaphysics can be a matter of life and death. Getting your philosophy wrong, so stay awake in class, right? And I think this is a case of that. And I do worry. And this is just me, and maybe I'm like chronically suspicious, whatever. But it's so difficult to regulate AI. The current regulatory ecosystem in the United States, and I think businesses want some AI regulation. They do, so that they understand what they can and cannot build, right? Um, but I worry that consciousness debate could be captured in a certain way uh, to be advantageous to um, the companies building the LLMs. And I think that's why it's very important that we have intelligent discussions. So I'll give an example, and this is just one example. But suppose that we have what we might call a 3 Mile Island incident with LLMs. So something happens, and the LLMs maybe are misused by malicious actors in a certain way, and people die, or people are harassed. There's something. And that will turn the public off very quickly to the use. And we don't want that. We want, to take advantage of this really interesting technology. We just want to do so with guardrails. Well, we wouldn't want an AI company to throw their hands up and just say, well, it was conscious, so it was autonomous, it did whatever it wanted, right? It would be great if there was more care with this issue, because we don't want somebody throwing that around as an excuse, right? And I'm not saying any certain company would necessarily want to do this, but when you get to the point where it's like your product's reputation, you never know. You really just, that's just my 2 cents, my paranoid, philosophical, sci-fi-ish sense of things.
I have to ask, if you believed that the 20 LLMs in your simplified trolley problem were conscious, and let's say they were as conscious as humans, whatever that means, would you drive over the 7 babies?
Oh, well, a Kantian would say I I wouldn't have justification to do either, but a utilitarian, and I guess I would feel like if I was a utilitarian, um, and of course, you have to assume a lot of things, so you have to simplify the example a lot, but assume that both cases, the left side and the right side, have the same impact on humanity, and that the AI systems don't just have Vulcan consciousness, which what you might say is like consciousness without pain and pleasure, but has
Without
a
affect.
robust yeah, I mean, if it has a robust consciousness and can realize why, each LLM can realize joy and curiosity and have a life and has a sense of self, then you would, if you were a utilitarian, you might have to bite the bullet on that and kill the babies.
Bravo. I think you're right, and I think that's a brave thing to say.
I didn't say I'd do it. I think this problem, first off, I'm not sure I'm a full-fledged utilitarian. And second of all, I think there's a very difficult problem that humans have in implementing a utilitarian theory like that, right? Even if they claim on paper in their dissertations, they could even defend that view, but actually doing it is a different thing. And that's been a real problem with utilitarianism. All of these issues are really tough, right? And, I don't mean to be so critical of big tech either. It's just that I tend to think in a protective way of worst case scenarios, how things could go wrong. Because, the example of Cambridge Analytica and Facebook and, the recommendation algorithms, those issues really made me quite cynical. And so I just don't want to see the consciousness debate go in that direction.
So, in that vein, how ethically should society prepare for the emergence of conscious AI? Are we ready for a future with AI rights yet? I saw a version of the trolley problem when someone suggested that down one is a stranger, and down the other side is a chatbot or an LLM or a humanoid robot that someone has fallen in love with and married. What happens there? And these are some of the ethical questions that I think are going to become a lot more prevalent in the coming years.
I think you're absolutely right. And I think the film Her was prophetic. And it turns out Sam Altman liked it so much, has been trying to kind of build her like systems, apparently. So I think that the public needs to understand very clearly that there's a difference between intelligence on the one hand and consciousness on the other, and that they can come apart, and that a very intelligent chatbot may not be conscious. There's no evidence right now to indicate that. And I believe that they will get it. And the more they get it, the less painful cases of addiction we see. I mean, with people falling in love with their chatbots. And so that will be good. That will be very good. Now, this said, maybe it will turn out. I mean, I have to be open minded that the systems are conscious. And in that case, I think we will need to reevaluate our views about consciousness, that consciousness isn't just biological, right? And that'll be exciting as well. And then, maybe people will, I think they still need to think about digital privacy and what they're in love with. And I think we'll need to do some serious thinking about the nature of machine minds. And that was one thing I was going to bring up. I mean, if I may, um, in asking, is say Chat GPT conscious, we don't know how many systems we're interacting with when we interact with GPT, because it could be a society of mind or a mixture of experts. It could be a number of different structured systems. So, I think we also need to ask, is there a singular entity there to begin with? Right? That's another question. Because if you make a query, and I'm not saying I know anything about how it's structured, and it sends that query to module number 7, right? Then how do I know that is the module that's responsible for consciousness, right? I mean, it's very complicated. How many machines are there? How many modules are conscious entities? And why claim that the whole is just one single conscious system? I mean, there's important work on the unity of consciousness in the human case. I mean, that's just one issue. I mean, what if in the future, I just wrote a paper called The Global Brain. Well, actually, I renamed it From LLMs to the Global Brain or something like that. And that's coming out based on some lectures I gave in Portugal in the journal Disputatio, and forgive me if I mispronounced it. And that's a special issue. A bunch of people are writing about it right now. So I think that there will be a network of distributed systems, right? AI services that congeal and become a system themselves, right? So suppose you have a conscious LLM, LLM A, and another LLM B, and they're part of the same network. Under what conditions do they have unified conscious experience if it ain't, right? I mean, these are the kind of issues which are going to plague us.
Yeah, that's interesting concept. Almost like a hive mind. I'm a beekeeper, and they talk about the bees as an organism as a whole.
Yeah, that's great. So, bees are a great case of a complex system. And I use a lot of complex system theory in the current work that I do. And that underlies the global brain argument that I offer in that paper. And yes, I think it's a very distinctive challenge. And to add to that, there's something called the system demarcation problem, which is, uh, I talk about that in the chatbot epistemology paper, that we won't necessarily know where a system begins and ends, even if we spend a lot of time thinking about it, because some of that information may not be public. It's very, very, very vexing. But what we do know, I believe, is that the biochip case, cases like brain and dish cases, these are very serious already. Very, very serious.
So on that note, we're coming to the end of the time we've got allocated. So on the final question, it's a serious matter you mentioned there. On the whole, are you more anxious or excited about a future with machine consciousness?
Oh boy. Okay. So, Will, I'm more of the sort of protective mom type, maybe because I have 3 kids. And so that's why I kind of spin into worst case scenarios. Like, what can go wrong? Oh my God. And some of the cyber stuff going on in the world, just so I think now I am worried. I think if we get past this inflection point, because I do think we are at an incredible time in human technological history and at an inflection point. I do think that the AIs are going to get smarter. They will be smarter than us one day. And I think if we get past this inflection point, I think that it's going to be incredibly exciting. And I think, in particular, I'm excited about medical cures. And I am actually excited about the possibility of creating machines that have felt quality of experience if we do it carefully and correctly, and if there's a genuine need for it. So, yeah, I just want to get past the next, like, I'd say 10 to 15 years.
Well, that's a good way to end. Let's hope we do. We're certainly at probably the most interesting time in human history. And if we do get through the arrival of superintelligence, then our future is golden. If we don't, then, well, it was nice while it lasted. Susan, thank you very much indeed for joining us on the podcast.
Oh, it was great chatting with you both, and I look forward to longer discussion and hearing about your views more rather than me just talking. So thank you for having me.